Photoelectric effect. Whenever the light of certain energy falls upon any metal surface, electrons are ejected from the metal surface, which is known as photoelectric effect. Photoelectric effect is mainly observed in the metals and the semiconductors. Here we have an example of sodium metal to understand the concept of photoelectric effect. When light of certain energy falls upon the sodium metal, electrons are ejected from the sodium metal. Now question arises over here. When the light of certain energy falls upon the sodium atom, why the electrons are ejected from the sodium atom? Answer to this question is that, as we know that light basically consists of photons, and each photon has a certain energy. Whenever photon falls upon any metal surface, it transfers its all energy to the electron. The energy transferred by the photon to the electron, if it is enough for the electron to come out from the metal surface, it is ejected from the metal surface. So in this case, the photon which falls upon the sodium metal, it has enough energy to give the electron, so the electron becomes free from the sodium metal. From this discussion can conclude that photoelectric effect can only be observed when photon of certain energy falls upon a metal, and this photon should have enough energy to give the electron, so the electron should be ejected from the metal surface. If energy of photon is less than the energy of electron inside the shell of an atom, then the photoelectric effect will not be observed. Now one more question is over here. Does the photoelectric effect take place for all the type of light energy? As in our universe, there are different type of materials over here, in which electron is bounded with different energies to the different atoms. Similarly, photons also have different energies. For example, when we're discussing X-rays, when we're discussing the gamma rays, and we're discussing the other rays over here, and discussing the visible light. So it shows that basically the photoelectric effect is dependent upon the two factors: nature of the material and the energy of photon. Nature of the material means how strongly is the electron bounded to the atom. If electron is bounded with a less energy to the atom, so you can supply a less energy photon to the atom and electron will be ejected from the metal. But if electron is strongly bounded with the atom, then you have to supply a very high energy photon to eject that electron from the metal surface and to observe the photoelectric effect. So from here we can conclude that photoelectric effect depends upon the two factors: nature of material and energy of photon. To further understand this concept, here we have a copper atom. Now here we have a one electron over here. If a photon falls over here, which energy is just equal to energy of this electron, so this electron will be ejected from the copper atom. But if a photon falls over here having less energy from this electron, so electron will not be ejected and it will remain inside the copper atom. So it means that basically photoelectric effect depends upon the energy of electron and the energy of a coming photon which falls upon this electron. If both energies are the same, then the electron will be ejected from the copper atom. Otherwise it will remain same in the copper atom. Energy provided by the photon to the electron, it is utilized by the electron in two ways. Now to understand this concept, here we have a model of photoelectric effect. This is photocell over here, on which whenever the light will be whenever the light will fall, electrons will be ejected from the metal. This part of a cell is known as photoemissive surface. Means that metal on which photon will fall, electrons will be ejected. This part of a cell is known as anode, which will collect the electron and electricity will be produced, or the current will be produced. Now this is controlling the frequency of the photon in this case. Here we have a source of a light. When we are moving towards the left, see to the wavelength, it increases. And when we are moving towards the right, wavelength is decreasing. But when we move towards the right, frequency increases and the wavelength decreases. But when we move towards the left, frequency decreases and wavelength increases. So it shows that there is a reverse relation between the wavelength and frequency. If frequency is increased, wavelength will be decreased. If you want to increase the wavelength, automatically frequency will decrease. Now here we have used an unknown metal over here at this point. Now we increase the energy. See, we have decreased the wavelength and we are increasing the frequency, but still the photoelectric effect is still not observed. When we increase the energy up to a certain level, then the electron starts come out from the metal surface. See over here. So this means at a certain frequency of photon, electrons are ejected from the metal surface. So before then, there is a classical concept in which it is said that energy of photon basically depends upon the wavelength. It is not dependent upon the frequency, which is found to be wrong. From here we can also learn that at the left, wavelength was maximum and frequency was minimum, but the photoelectric effect was not observed. But when we move towards the right, frequency was increased and wavelength was decreased, so the electron came out from the metal surface. What we have said before, we have said that photoelectric effect basically depends upon the metal, nature of the metal, and the energy of photon. So we have not changed the metal was same, but we were increasing the energy of photon when we are moving towards the right and increasing the frequency. So it means that energy of photon is dependent upon the frequency, not upon the wavelength. Now at this certain frequency, photon have only that much energy that it can take out the electron from the metal surface, but it is not able to give the kinetic energy to the electron. So when we increase from this level over here, more energy is transferred by the photon to the electron. So by that energy, electron also gets the kinetic energy and come out from the metal surface, and current is produced in the photocell, which is shown over here. So that we conclude over here, photon energy is utilized by the electron into two parts. One part, a certain part of energy, is utilized by the electron to come out from the atom, and second part of the energy is utilized by the electron as the kinetic energy. So we sum up our conclusions. Energy is gone into two parts by the electron, which is given by photon. One part of energy is utilized by the electron to come out from the atom, and second part of the energy is utilized by the electron to move further, which will be a kinetic energy. So we can write in word equation as photon energy is equal to energy required to remove electron from the shell plus kinetic energy for the electron to move. So these two energies sum will be equal to the photon energy. Energy required to remove the electron from the shell is called as work function, which is denoted by the phi, and kinetic energy of the electron will be denoted by the k dot E, means kinetic energy. Energy of photon is given by the mathematical expression that E is equal to h into mu, where mu is the frequency of photon. As we have discussed before, the energy of photon depends upon the frequency, not upon the wavelength, and h is the Planck's constant over here. So when we sum up all this in the mathematical equation, so it becomes h mu, means that total energy of photon is equal to phi plus kinetic energy, where phi is that much energy which is required by the electron to come out from the atom, and second part of the photon energy is utilized by the electron to move further, so it becomes kinetic energy. Now we discuss another case over here. Now here we have used an unknown metal to observe the photoelectric effect. So where it was started at 5.08. So when the photon have energy equal to this much, in that case photon take out the electron from the metal surface, but photon is not able to give the kinetic energy to the electron. So electron just remain over here over the surface of the metal, and it cannot move further. So this means the kinetic energy of the electron is zero. Electron is just only ejected by the metal and it stays over the surface of the metal, but it does not have kinetic energy to move further. So this means kinetic energy will become zero. So the mathematical expression that we discussed before, in that case kinetic energy will become zero, and total energy supplied by the photon to the electron will be utilized by the electron to come out from the atom. In that case h mu will be equal to phi, where phi is known as work function, or that much energy required by the electron to come out from the metal surface. It is the same over here. When the light falls upon the metal surface and electrons are ejected from the metal surface, but it stays over the surface, it cannot move further. If we draw a graph between the voltage produced by the photocell and the frequency on the x-axis, or the mu along the x-axis, if we extend this graph touches the x-axis at a certain value which is known as mu naught. Mu naught is known as threshold frequency. It has a certain value for certain matter. So this mu naught is known as threshold frequency, and it will have certain value for certain matter. If we supply a photon which have minimum energy equal to h mu naught, then the electrons will be ejected from the metal surface, and if the energy of photon will be less than this energy, then the photoelectric effect will not be observed and electrons will not be ejected from the metal surface. So the certain devices which have a solar cell in it, they works in the sunlight, but when they carry to bulb or tube light, they doesn't work. So what it means? It means that the energy supplied by the photon which belongs to sunlight has enough energy to take out the electron and produce the electric effect, photoelectric effect. But the photon which belongs to a tube light or a bulb, it does not have enough energy to take out the electron from the metal surface, and photoelectric effect is not observed. Thanks.